call is now being recorded.
Good morning. So in this video tutorial, we are going to start with the sorting algorithm series. So now I'm going to give you a short introduction to sorting algorithms. So before moving to the types of different types of sorting algorithms, so we are going to learn what is a sorting algorithm, what are the different terminologies used in sorting algorithm, different sorting algorithms. So sorting algorithm is nothing but putting something in order. So we are having a list of items. We can arrange those list of items in some order according to the favorites. For example, if you're having a list of websites viewed by the user, that we can arrange in some order, like who visited. Sometimes some websites are visited for few hours, some web pages are visited for a few minutes. Okay, according to that visiting time we can arrange the websites. Or TV channels, we can have favorites list, right? So for example, today I'm watching one particular channel for longer time, means according to the longer viewing time, our channels are stored in the favorites list. Okay, so for example, if you're having a list of numbers in our hands, we can arrange it in some order, alphabetical or ascending order or descending order. If you're having letters in our hands, we can arrange in alphabetical or reverse alphabetical order. So sorting algorithm is used to arrange some items in some order, either alphabetically or numerically. In simple terms, we can say alphabetical or in numerical order we can arrange the list of items. That is the purpose of sorting algorithms. Okay, and different terminologies are used in different types of sorting algorithms. So we are going to see few. One is in place sorting algorithm. In place, in the name itself you can understand, if you're having list of items, it sorts the items in place without using extra space. Or sometimes we can say it uses constant extra space. So constant space for all type of sorting algorithm, it may be any type. If you're swapping two items, we are in need of one temporary variable. Okay, so before swapping, we'll store the first item in the temporary variable, and from the temporary variable to the second item. Likewise, for swapping, we need a temporary variable. So that is the extra space apart from the n elements. Okay, if you're having 9 elements, so one more space is needed for swapping or for exchanging. Okay, so for some sorting algorithms, it uses extra space. Okay, constant extra space. Some sorting algorithm, it uses, if we are having n elements, it uses n spaces. Okay, it changes. Okay, so that is not in place sorting. In place sorting means so without using extra memory space or with the help of some constant space, it sorts the list. Okay, that is in place sorting algorithm. So insertion sort and selection sort are in place sorting algorithms. So it does not use any additional space. Okay, apart from the n element space. And merge sort and counting sort is an example of not, it is not a in place sorting algorithm. It uses n extra space used for sorting. So this is the first terminology, in place sorting. Some sorting algorithms are in place sorting algorithm, and some sorting algorithms are not in place sorting algorithm. And the next terminology is external and internal sorting. So some sorting algorithms uses external memory space. For example, if you're going to sort a list of items and load it into the database or load it to the memory, if our memory space is too small to hold a large set of data, so that time it uses external storage like hard disk or CD or pen drives to store the remaining data, to hold the remaining data. Once the first list is sorted and it is loaded, then the second list is taken from the external storage. Then it is sorted and it is loaded. So this type of sorting is called as external sorting. So it means all data needed to be sorted. I'm having a list of, I'm having a large set of data. So that cannot be placed in the memory. So that time we'll load some set of data in external storage. So that type of sorting is called as external sorting. And in some cases, if you're having a small set of data, all the items we are going to sort is loaded into the memory. So that time it is called as internal sorting. So this is the two terminologies, internal sorting or external sorting. And the next terminology is stability. So stability, some sorting algorithms are stable sorting algorithms, some sorting algorithms are unstable. So that is very, very important terminology in sorting algorithms. So this would be considered while we are choosing sorting algorithms. So stability, for example, here you can see that example balls, different colors of balls with a number, okay, with a value is listed, 5 balls. So two balls of same value 5, and two balls of same value 15, and one ball with a value 30. So we are going to sort these items. So the input array is of the order 5, 30, 15, 5 and 15. So after sorting, you can see there are two fives. So first 5, that is yellow color ball is placed first, then the green color ball. So it is not sorted. If two items are of same value, it is placed in the same position, okay, in the input array as well as in the sorted output array. So this is called as in stable sorting algorithm, stability. Okay, so when you read this, if two items with equal keys appear in the same order in the sorted output as well as in the input array, that is called as stable. Okay, say stable sorting type. So bubble sort, insertion sort, merge and count sort are stable sorting algorithms, and quick and heap sort are not stable algorithm. It rearranges the items with same key values. Okay, so it takes time to arrange the same item. So this is about the stability in sorting algorithms. And the next one is, some sorting algorithms are of type comparison, or some sorting algorithms are non-comparative algorithms. A few algorithms are non-comparative. Most of the algorithms uses the technique comparison. So two items are compared, two values are compared, then it sorts the list accordingly, either in ascending order or descending order, a longer viewing time or visiting time or favorites. So some comparison is there. Okay, so that type of algorithms are called as comparison based sorting algorithms. Some sorting algorithms, or few sorting algorithms, will not compare. Simply, it categorizes the item. Okay, we can say correctly, without comparison, it categorizes. Okay, so it checks and it categorizes. Okay, not compares two items in this list. Okay, so bin sort and radix sort and bucket sort and radix sort are examples of non-comparison sorting algorithm. Apart from that, all other algorithms uses a comparison approach. It compares item and it sorts. And here the complexities are given in the video tutorial. Individual sorting algorithms video tutorial will see all these things. And some sorting algorithms are stable. I already told you what is stability. And here bubble, insertion, merge comes under stable sorting algorithm. Other algorithms are not stable algorithms, stable sorting algorithms. Quick sort algorithm, it depends upon the list, depends upon the implementation. And some sorting algorithms are in place sorting algorithms, and some sorting algorithms are not in place sorting algorithm. A good example is merge sort is not in place sorting algorithm, because it is used for external, it can be used as external sorting method. Extra remaining elements are in the external storage. Apart from that, all other elements are in place sorting algorithm uses in place sorting terminology. Without using extra space, it sorts the list. Merge sort, it uses extra space. If you're having n elements, it uses n extra space to sort the list. Temporary storage, it needs temporary storage. So merge sort is not a in place sorting algorithm. And most of the algorithms are internal sorting. Merge sort is can be used as internal as well as external. And some of the real world examples, applications are given. So you can read it. So merge sort is mainly used for sorting a set of datas in the database when we are loading it to the memory. Okay, and bubble sort mainly used to sort the it is used to programming TV remote, sorting channels based upon the longer viewing time. I already told you. Heap sort mainly used to read barcodes in the plastic cards, and quick sort in sports. They'll organize the win loss ratio with the help of quick sort. How many times this team won the match, and in this particular location, how many times and which team won the match most of the time. Okay, so that kind of organization is done with the help of quicksort. And radic sort for bidding, for listing, sorting the listings by the current bid amount with the help of radic sort. And selection sort, usually in general we'll use selection sort to sort the items, sort the people, or sort the list alphabetically or numerically. We'll use selection sort. Selection sort, it uses minimum number of swaps compared to all other sorting algorithm, but it is used for small set of items. If the list is small, we can go for selection sort. And bucket sort for sorting the people or categorizing the people. That time we can go for bucket sort, youngest to oldest, or this group 1 to 10 years, 11 to 20 years, that time, in order to group the people, or in order to group according to some category, so we can go for bucket sort. So this is about the introduction to sorting algorithms. So we'll see each and every algorithm in detail. Okay, thank you.